Hello everyone, welcome to Sweetie Speaks official YouTube channel. Today we are going to learn about UVM Testbench and different components in UVM Testbench. Let's first understand some basics about the UVM Testbench. First thing to understand is that UVM Testbench is a layered testbench. There are different layers. What are these layers? We are definitely going to see. For now, just remember that it is a layered testbench structure. The next point is it is object oriented, which means we are going to use a lot of classes to build this testbench. If you have not gone through System Verilog OP series, I recommend you to please go through that first. We have one series in this channel itself, Sweetie Speaks Official. So please go and understand those system Verilog OOPS concepts so that you understand what is object, what is class, because we are going to use those concepts in UVM. The next thing is each component. UVM test bench has a lot of components and each component in the UVM test bench has a predefined purpose. What are these components? What is their purpose? We are going to see in the upcoming slides. But for now, remember, there are a lot of UVM components and every component has a predefined purpose. UVM Test Bench provides you with a reusable verification environment. Reusable means you can reuse that environment throughout different versions of your project. No need to create it from the scratch. It is a reusable verification environment. Another thing is in UVM test bench, we try to work at transaction level because that is more efficient way. Finally, we are going to deal with transactions only. Now let us see different UVM test bench components. First, we will see DUT. DUT is design under test. This is your actual design which we want to verify. Now this DUT, design under test, is connected to transactors. The example is driver and monitor. What are these transactors? Transactor, for example, driver. What does driver do? It it will take the sequencer. It will take some sequences from the sequencer, and this sequences provides information at the transaction level. And then this driver converts it into the pin level before giving it to the DUT. So the driver is converting something from transaction level to the pin level or the signal level. That is why it is a transactor. What does monitor do? Monitor collects the information from the DUT, the signal information from the DUT, and converts it into the transaction, which will then be used by some UVM components like scoreboard. Like so, driver is something which is converting your transaction level information from sequencer to the signal level information which goes to DUT. Monitor is collecting your signal level information from DUT and converting it into the transaction level information which is used by UVM components like scoreboard. And your design under test is connected to such transactors. One thing which you need to understand is that design under test interacts with the test bench at pin level, not at the transaction level. For example, driver is connected to DUT and finally it is converting the information which is in transaction level from sequencer, and before giving to DUT, it converts it into the signal level. Similarly, monitor is receiving the signal level information from DUT and converting it into the transaction level which is used by UVM components like scoreboard. So finally, it your design under test is interacting with test bench at pin level or signal level only, and later on we are converting it into the transaction level. How is DUT connected to test bench? It is connected to the test bench via interface. So interface is one of the test bench components which is in between your test bench and your DUT. What is interface? Interface is something which connects your DUT and test bench at pin level. You need to understand that one test bench can have multiple interfaces. Say in my design, I am using different protocols. I am using AXI. I am using USB. So I will have different interfaces, one for AXI, one for USB. It means my test bench is now having multiple interfaces, each interface for a different protocol. So depending on your design complexity and requirement, it is possible that you have a test bench that has multiple interfaces. Each interface will have its own UVM agent. For example, for AXI interface, you will have a different AXI agent. And for USB interface, you will have its own USB agent. Okay, so each interface should have its own agent. Now, what is a driver? Driver drives randomized transaction to DUT at pin level. So we had discussed that driver collects the transaction information from the sequencer. So this driver is connected at the top to a UVM component called a sequencer, and it collects those transactions and converts it into the pin level, which is then given to the DUT. So this information is used to drive the DUT. You are providing some input to the inputs of DUT so that it generates some output. What does driver do? It will retrieve sequence items from the sequencer. Sequencer has something called as sequence items, and it will retrieve that information. It will retrieve the interface handle from the configuration DB. Your configuration database has some interface handles which will be retrieved by your driver. And then it will drive the transaction to the design under test. It will drive the transaction using the interface handle which it got from the config DB. So mainly through all this process, it is providing some stimulus to your design so that the design inputs are driven and then your design will generate some output. What is a sequencer? A sequencer is made up of data items which will be put together in different ways to create interesting scenarios. And these data items are sequences or sequence items. So when you put together these sequence items in very different ways, you will create some interesting scenarios. And with this interesting scenarios, you can find some bugs. We are going to see in detail about how these things work in upcoming lectures. But for now, please remember that sequencer has something called as sequence items, and they are used to generate some interesting scenarios. It generates some randomized transactions which will be sent to the DUT via driver. We already discussed that driver takes some transactions from the sequencer and then it provides it to the DUT in the form of pin level information. For the maximum benefit or to generate maximum interesting scenarios, we try to randomize these transactions. We are going to see how we are going to randomize these transactions in the upcoming lectures. For now, please remember that sequencer generates some randomized transaction which will be sent to the DUT via driver. You can think of sequencer as a mediator to establish connection between your sequence and your driver. What does a sequencer do? It passes transaction or sequence items to the driver. It provides this information which is transaction, or I can call it as sequence item. This information is provided to the driver, which will then be used to drive your DUT. This is the main work of the sequencer. Now, in the UVM test bench, there is also an object. This is not a UVM component. It is a object. It is derived from UVM object. It is extended from UVM object. It is not extended from UVM component. So in your UVM test bench, there is a UVM sequence item class which is extended from UVM object. Remember this, it's a UVM object, not a component. So it is extended from UVM object. You can consider sequence item as a transaction. This is used to generate the stimuli for your verification. Stimuli means we are providing some inputs to the design so that it generates some output. As we said, we try to generate random stimulus. So we are going to generate sequence item using randomization. Then the sequence item is sent to driver from your sequencer, and this driver then provides it to the DUT in the form of pin level or signal level information. What is a UVM monitor? See, driver, it drives the design input. Monitor does the reverse. It monitors the design input. Driver, what we did, we provided some inputs to the design. When you provide some inputs, design generates some output. So this monitor will observe your output. It will see what is your output. It will monitor your design output. That's why it is called as monitor. So it will capture the signal activity from your design under test, whatever the outputs generated, it will capture that and it will translate it into the transaction so that you can send it to other components like scoreboard. It collects the pin level or signal level information from your design and translate it into the transaction level information. What does monitor contain? Monitor contains a virtual interface handle. This virtual interface handle is connected to the actual interface that your monitor wants to monitor. Say for example, my monitor wants to monitor something on AXI. So it will have a virtual interface handle, and that interface handle will be connected to your AXI interface because you want to monitor the activity at AXI. It also has something called as TLM analysis port. What is this TLM analysis port? We are going to see in detail in upcoming lecture. For now, please remember that monitor has something which is called as TLM analysis port, whose job is to broadcast this captured data, whatever data or signal information which monitor collected and then converted into transaction. This needs to be broadcasted to other UVM components where it will be used. This is performed by something called as TLM analysis port inside the monitor. Monitor will also have knobs to enable or disable protocol checking and coverage. So say for example, I want to collect the coverage, then I have some coverage collectors, and it is possible that for some instances I want to disable the coverage. To enable and disable, there will be some switches or knobs which can be inside your monitor. Similarly, for enabling or disabling some protocol checks. Say for example, I have a design which has two USB ports. One is version 2.0, one is version 3.0. And say for example, I want to now run a test for USB 2.0. So that time I can disable the protocol checking from USB 3.0 and just enable for 2.0. Like this, however you want your test to work, whatever is the requirement, you can enable and disable your protocol checking and coverage as per your requirement. This facility is available inside your monitor. What are functions of the monitor? It will collect the signal information through something called as virtual interface. Here we already discussed about virtual interface handle, which is connected to your actual interface. So through this, you are going to collect your signal information because virtual interface has all the nets or the signals, and you can use this virtual interface to collect the values of your signals. Then we will use this collected data for some protocol checks or coverage, whatever we want to do. We will use this signal level information from the monitor. Collected data, whatever is collected by monitor, is exported by something called as analysis port. Exported means it is broadcast to other UVM components where it can be used for whatever purpose, say coverage collection or some checks. Now let's see what is agent. Agent is something which embodies all protocol specific information. Embodies means it contains everything which is required for a protocol. Say for example, I have a AXI protocol. So whatever information or components required for AXI protocol will be present inside your agent. You can consider it as a kit, a complete verification component kit for some given logical interface. Say it can be AXI, USB, I3C. So it is a complete verification kit. Whatever verification components are required for your protocols, it is present inside your agent. What does it consist of? We said that it consists of all verification components required. What are these verification components? It will have driver. It will have your sequencer. Sequencer, we saw that it generates your stimulus. So it is also called a stimulus generator. And then it has your monitor, and if you want to do coverage collection, it will also have your coverage collector. So agent consists of driver, sequencer, monitor, and optionally coverage collector. Let's see what is an environment. Environment contains multiple reusable verification components. In the environment, you can define the configuration of your components. All your components can be configured using different configuration, and this configuration is a part of environment, and you can configure all your verification components as per your application or use case. Let's take one example, a UVM environment which contains multiple agents. Say I have AXI also, USB also, so I'll have a agent for AXI, I will have a agent for USB, two agents. Then I will also have a scoreboard. What is scoreboard? We are going to see. I'll have a coverage collector because I want to do coverage collection. So all these things will be present inside your environment itself. Agent, scoreboard, coverage collector. And additional checkers if you want to do some additional checks. It can also have some smaller block level environment. In case say you are at the subsystem level and you have a subsystem environment. So this subsystem environment can have your smaller environments which are IP environments or the block level environments. So your environment can contain other environments. Now let's talk about scoreboard. This is one of the very important components. It is a checker. It checks your verification. It checks the outputs of your DUT. How does it do? Let's see. It verifies your design functionality. What does it do? It will first collect your transactions which are sent by the monitor. We already discussed that monitor will collect your design outputs. You have sent some inputs from the driver, and afterwards your design generated some outputs. These outputs are collected by your monitors and they are converted in the form of transaction. Then scoreboard will predict the expected output. You have the actual design output which was collected by the monitor. Now you need to predict some output depending on your DUT. We have something called as predictor or reference module in reference model, predictor or reference model we call it. In UVM, we are going to see what is this predictor or reference module. It is a part of scoreboard and its job is to predict the expected output. Then it will compare your predicted expected output which you had predicted and your actual output from the monitor. If both these outputs are matching, your DUT is performing properly. If there is a mismatch, there is a possibility of some bug. So you can find some design bugs if your expected and actual outputs are mismatching. Let's talk about subscriber. Subscribers can be called as listeners to an analysis port. If you remember, monitor had an TLM analysis port and subscriber can be a listener to that analysis port. It can also be called as an extended version of analysis port, which is actually analysis export. So it is an extended version of analysis export. It listens to your analysis port. So it is an analysis export. This subscriber provides you an analysis export for receiving transactions from a connected analysis export. Okay, so it is connected to an analysis export from which you can receive the transactions. Since it's a subscriber, it is subscribed to any transaction which is emitted by a connected analysis port. So it is connected to an analysis port from where it will listen to all the transactions which are emitted. This subscriber will provide you a write method. This write method is used to receive the transactions. So in short, just think of subscriber as a listener to an analysis port. You can call it as an analysis export which is connected to analysis port, and it can listen to any transaction to its connected analysis port. It provides a write method to receive these transactions. Now what is test? Test is a pattern to test and verify your design functionality. You need to define different test scenarios for your test bench to test your design under test. Right? So what does this test contain? This test will contain your environment. It will contain the configuration properties. So there are different configurations possible in your design. You can do it in the test, and there will be some class overrides. What does the test do? The test will enable or disable agents as per your requirement. Like say for example, right now I am just running some test on AXI, so I don't need USB. That time I will disable the USB agent and I will only enable my AXI agent. Then it can change the variable values inside your configuration if you want to have some different configuration, if you want to turn on and off certain components in your design for your particular test. Using some configuration variables, you can do it from the test. You can run different sequences on many different sequencers in the verification environment from the test. So this test contains some environment, verification environment, and this environment will contain the sequencers which will contain sequences. So you can run these different sequences on many different sequencers which might be present inside your verification environment using test. What is top? Top can be thought of as a static container. Static means it's not dynamic. It can't be changed. Once defined, it will remain static. And it will hold everything that needs to be simulated. What needs to be simulated? If you really want to test something, you first need to simulate that design. Then the interface which connects your design to the test bench, and then all your test bench components. So it will contain everything. It can be considered as root node in your test bench hierarchy. It's like the top. It has everything in your test bench. So it is the top of your test bench. All the test bench components which we saw earlier are present inside your top. What does it instantiate? It will instantiate all your verification components. It will instantiate interfaces that connect your verification components with the design, and it will also instantiate your design. So whatever you need to run your test, verify your design, everything is present inside your test bench top. I hope now you understood about UVM test bench. In the upcoming lectures, we are going to see more details on this UVM test bench. To stay tuned, please subscribe to Sweetie Speaks official YouTube channel. Thank you.